Welcome to section 521. We're going to be talking about solving inequalities in two variables. What we're going to be mostly talking about is solving quadratic inequalities. So now, when we solve a quadratic inequality, keep in mind, less than, greater than, we don't include those solutions. We're going to use an open dot. When we see a less than or equal to or greater than or equal to, we do include those. We're going to use a closed dot or a solid dot. Now, we're going to treat this and get everything equal to 0. So the first thing we're going to do is we're going to subtract x squared from both sides. We're going to subtract the 4x from both sides. We're going to subtract the 3 from both sides. So that gives us the equation x squared plus x minus 6 less than or equal to 0. Now, we stop thinking about it as an inequality and think about it as an equation. We'll come back to the inequality in a moment. X squared plus x minus 6, and we're going to treat it as equals 0. Now, we can factor this. We get x and x. To multiply to negative 6 and add to 1, we're going to have a positive 3 and a negative 2. X plus 3 equals 0. X minus 2 equals 0. So x equals negative 3 and x equals positive 2. Now, we come back to the inequality. These are our endpoints. Now, we don't know if we're going to have an and inequality or an or inequality. So negative 3 would be over here, and positive 2 would be over here. Looking that we have less than or equal to, we're going to use a closed dot, a solid dot. And to determine if we shade in between or in opposite directions, we're going to pick a test point. I like to pick a test point in between. So we're going to test when x equals 0. So going back into the inequality again, 0 squared plus 0 minus 6 is less than or equal to 0. So we get negative 6 is less than or equal to 0. That's a true statement, which means 0 was a solution. So that's where our solutions are going to be, is between negative 3 and 2. So our solutions isn't just one value, it's an entire range of values. It's all the values in between negative 3 and 2, including those. So the way we would write our answer, x, and that's going to be between negative 3 and 2. X is greater than or equal to negative 3 and less than or equal to 2. So x is between negative 3 and 2. There's our solution. For problem number 2, we're going to ignore the inequality for right now and write x squared plus x minus 6 equals 0. We're going to solve the equation. So we have x and x. To multiply to negative 6 and add to 1, we have a positive 3 and a negative 2. X plus 3 equals 0. X minus 2 equals 0. So x equals negative 3 and x equals 2. Now we're going to come back to the inequality. Negative 3 and 2 on the number line. Now this time we have just a less than, so it's going to be an open dot. We're not going to include this in our solutions. Pick a point in between. I like using 0 if I can. And we'll go into the inequality. 0 squared plus 0 minus 6 is less than 0. So negative 6 is less than 0. That's a true statement, which means our shading is going to be in between those two. So what we have here, our solution, x is between negative 3 and 2. And because it's open, we just put our less than signs there. And that's all of the solutions. It's all the numbers between negative 3 and 2, not including negative 3 and 2. For problem number 3, It's already at 0, so now treat it as an equation. Ignore the inequality. X squared minus 3x minus 10 equals 0. We'll come back to the inequality in a little bit. We can factor this. X and x. Now to multiply to negative 10 and add to negative 3, we have a negative 5 and a positive 2. So x minus 5 equals 0. X plus 2 equals 0. So x equals 5 and x equals negative 2. Now looking at the inequality, on the number line, we have our negative 2 on the left and our 5 on the right. Because it's or equal to, we're going to put our solid dots. Now we want to try a test point. X equals 0. Back to the inequality, 0 squared minus 3 times 0 minus 10 greater than or equal to 0. So 0 squared is 0, minus 3 times 0 is 0, so we get negative 10 is greater than or equal to 0. That didn't work, so our shading is not going to be in between, it's going to be in the outside regions. It's going to be what's called an OR inequality. Now I show you why that's going to be the case by picking a point like negative 3 on the left-hand side. So we get negative 3 squared minus 3 times negative 3 minus 10 greater than or equal to 0. So negative 3 squared is 9. Negative 3 times negative 3 is plus 9 minus 10 greater than or equal to 0. So 9 plus 9 minus 10 is 8. Greater than or equal to 0, that's a true statement. You can see a value over here would work. And if x were equal to 6, for example, on that right-hand side, 6 squared minus 3 times 6 minus 10 greater than or equal to 0. So we get 36 minus 18 minus 10 greater than or equal to 0. 36 minus 18 is 18 minus 10, so we get 8 is greater than or equal to 0, which is also true. So you can see the outside regions work. So when we write this, you just take the left-hand side, and that inequality is x is less than or equal to negative 2. The right-hand side, x is greater than or equal to 5. And then you just put OR back at the end, and there's our solutions. All right. Number 4. Same thing, treat it as an equation. X squared minus 3x minus 18 equals 0. So when you factor, you get x and x. Multiply to negative 18 and add to negative 3, you get negative 6 and a positive 3. X minus 6 equals 0. X plus 3 equals 0, so x equals 6. X equals negative 3. Negative 3 here, 6 here, because it's just a less than. They have open dots at the negative 3 and the 6. Pick a test point in between. That'll tell you where to shade. Let's pick x equals 0 because we can. 0 squared minus 3 times 0 minus 18, and we're back in the inequality less than 0. 0 squared is 0, minus 0 minus 18, so we get negative 18 is less than 0. And that is true. That worked. So our shading is in between. It's that end inequality. So our solution, x is between negative 3 and 6. And here, with an end inequality, just put our less than signs because it's open dots. And there it is. Number 5. Same thing, treat it like an equation. X squared minus 3x minus 10 equals 0. Factor. To get negative 10 and add to negative 3, we get minus 5 and plus 2. x minus 5 equals 0. X plus 2 equals 0, so x equals 5, x equals negative 2. Use your number line. There's negative 2 over here, and 5 over here because it's just less than, open dots. So test, 0 is a good one because it's in between. Back into the inequality, 0 squared minus 3 times 0 minus 10 is less than 0. So we get negative 10 is less than 0. And that's true, negative 10 is less than 0, so our shading is in between. If it works, shade in between. If it doesn't work, shade in the opposite regions. So now our solution, x in the middle, negative 2 on the left, 5 on the right, and because it's open dots, we just put our less than symbols there. And there we have our solutions. Now for number 6. Another factoring problem. 2x squared plus 13x plus 6 equals 0. A little bit more complicated to factor. We got our first and last terms. We got our 12x squared, our positive 13x. Now, what we have to think is they have to multiply to 12 and add the 13. Top number is positive, the signs are the same. Bottom's positive, they're both positive. Now, the only factors of 12 that add the 13 are 12x and 1x. So we've got our 2x squared and our positive 6. So then in between, we get our plus 12x plus 1x. Grouping, the common factor is 2x times x plus 6. Common factor is 1 times x plus 6. So that gives us x plus 6 times 2x plus 1. So our factors, x plus 6, 2x plus 1, set each factor equal to 0, x plus 6 equals 0, 2x plus 1 equals 0, get x equals negative 6, x equals negative 1 half. All right, so now negative 6 is over here, negative 1 half is over here, and 0 is over here. So we have to pick a point in between. Now we're going to use open dots because it's just greater than, not or equal to. And I can't use 0 as my test point. I want to pick a point in between. Because if it works in between, it's an and. If it doesn't work in between, it's an or. So now, let's pick a test point. I'm going to test x equals negative 1. Because negative 1 is over here. So now, back to the inequality. 2 times negative 1 squared plus 13 times negative 1 plus 6 is greater than 0. Negative 1 squared is 1 times 2, so it's 2. 13 times negative 1 is minus 13 plus 6 is greater than 0. 2 minus 13 plus 6. That's going to be negative 5 is greater than 0. That's not true. The value in between doesn't work, which means our shading has to go in the outside regions. Our graph would look like this. So our solution would be an or inequality. So just look at the left-hand side. X is less than negative 6. And for the right-hand side, x is greater than negative 1 half. And to finish it up, just put an or in between. And there's all of our solutions for that inequality. Okay, in the next video, we're going to talk about absolute value inequalities. And it's very similar to what we just did. And then we'll finish up by graphing some of these. Okay, thank you, and I will see you in the next video.